Hello everyone, welcome. I'm Professor Diwa, back with another math video. In this video, I'll be going over domain and range of graphs and piecewise functions. Our objectives: find the domain and range from a graph, graph piecewise defined functions. Okay, so let's get started. In our first example, it states, for each graph, find the domain and range and state if it's a function. For the graph of part A, you could see that this graph would not pass the vertical line test and would not be a function. Next, we need to find the domain. The domain would include all of the x values on the x-axis that are used by the graph. Now, if we take a look at the graph, you could see that the graph does not extend beyond the x value of -4. You could see here it starts at -4 and uses all of the x values going up until we get to +4. So our domain, written in interval notation, would be bracket -4, 4, close bracket. Now to find the range. If we take a look at the y-axis, you can see that our graph doesn't use any y values below -2. It uses the y values above -2 all the way up to +2. So we write our range using interval notation, bracket -2, 2, close bracket. For part B, you could see that this graph would pass the vertical line test, so this graph is the graph of a function. Now for the domain. If we take a look at the x-axis, you could see that our graph starts at the x value of -3 and uses all of the x values from -3 all the way to +5. So our domain is written as bracket -3, 5, close bracket. Now to find the range, if we take a look at the y-axis, you could see that the smallest y value that our graph uses is -2, and you could see the largest y value that this graph uses is +4. So we write the range as bracket -2, 4, close bracket. Moving on to part C, you could see that this graph would pass the vertical line test, so this is the graph of a function. Now to find the domain. If we take a look at the graph, you can see that it extends downward and also goes to the left and towards the right. This means that our graph uses all of the x values going from -infinity to +infinity. So our domain is written as parentheses, -infinity, infinity, close parentheses. Now to find the range. If we take a look at the y-axis, you can see that the highest y value our graph uses is +4. We can also see that our graph uses all of the y values below 4 going towards -infinity. So we write our range as parentheses, -infinity, 4, close bracket. Next, we have a practice problem for you to try. For each graph, find the domain, range, and state if it's a function. Okay, so pause the video, try out the problems, and then check back with the video to see the answers. Alright, so let's get started with part A. You could see that this graph would pass the vertical line test, so this graph is the graph of a function. For the domain, you could see that the smallest x value on the x-axis that this graph uses is -2, and the largest x value that it uses is +4. So our domain is written as bracket -2, 4, close bracket. For the range, you could see the smallest y value on the y-axis that our graph uses is -3, and the largest y value is +4. So we write our range as bracket -3, 4, close bracket. Moving on to part B, you can see that our graph does not pass the vertical line test, so this is not the graph of a function. For the domain, you can see the smallest x value that this graph uses is -2, and the largest x value is +2. So we write bracket -2, 2, close bracket for our domain. Next, our range, you can see the smallest y value that this graph uses is -2, and the largest y value is +2. So our range is written as bracket -2, 2, close bracket. Moving on to part C, you can see that this graph would pass the vertical line test, So this is the graph of a function. Because this graph extends in the left and right direction, as well as in the up and down direction, this means that our graph uses all of the x values on the x-axis for the domain, as well as all of the y values on the y-axis for the range. The domain for this graph would be parentheses negative infinity, comma infinity, close parentheses, and the range would be parentheses negative infinity, comma infinity, close parentheses. Moving on to example number 2, it states, evaluate f of 2, f of negative 6, and f of 0 for the following function. Here we have a piecewise function f of x. This is equal to 2x plus 3 if x is less than or equal to 0. And then f of x is equal to negative x minus 1 if x is greater than 0. To find f of 2 for this piecewise function, we need to plug it into the appropriate equation. We can either plug it into the top or the bottom equation. If we take a look at the top equation, you can see it's defined specifically for x values that are less than or equal to 0. We can see that 2 is not less than or equal to 0, so we don't use the top equation. If we take a look at the bottom equation, it's defined for x values greater than 0. And 2 is greater than 0, so we plug it into the bottom equation. We get f of 2 is equal to negative 2 minus 1. Simplifying this, we get negative 3. Next, we need to find f of negative 6. Because negative 6 is less than or equal to 0, we're going to use the top equation. So we get that f of negative 6 is equal to 2 times negative 6 plus 3. Simplifying this, we get negative 12 plus 3, which is equal to negative 9. Next, we need to find f of 0. Because 0 is less than or equal to 0, we use the top equation. So we get that f of 0 is equal to 2 times 0 plus 3. Simplifying this, we get f of 0 is equal to 3. Next, we have a practice problem. Evaluate f of 2, f of negative 6, and f of 0 for the following function. Here we have the piecewise function f of x equals 3x minus 1 if x is less than or equal to 2, and f of x is equal to negative x if x is greater than 2. Okay, so go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Alright, so let's get started. For f of 2, this is equal to 3 times 2 minus 1. Simplifying this, we get 6 minus 1, which is equal to 5. For f of negative 6, this is equal to 3 times negative 6 minus 1. Simplifying this, we get negative 18 minus 1, which is equal to negative 19. For f of 0, this is equal to 3 times 0 minus 1, which simplifies to negative 1. For example number 3, graph each of the following functions. For part A, we have the piecewise function f of x equals 2x plus 3 if x is less than or equal to 0, and then f of x is equal to negative x minus 1 if x is greater than 0. To graph this piecewise function, we're going to graph it in parts. First, I'm going to graph the top equation and then the bottom equation using the point plotting method. Starting with the top equation, we only use x values that are less than or equal to 0. So when I create my xy chart, the x values I'm going to use are 0 and then anything less than 0. So I'm going to use negative 1. Next, if we plug in the x value of 0 into the top equation for x, we get 2 times 0 plus 3. This simplifies to 3. So our f of x value here is 3 in our chart. Next, if we take the x value of negative 1 and plug it into x for the top equation, we get 2 times negative 1 plus 3. This would simplify to 0. So we get 0 for our f of x value. Now that we have both the x and y values for our points, we can go ahead and plot them on the graph. at 0, 3 is our first point, and then at -1, 0, we have our second point. Now this portion of the graph only uses x values that are less than or equal to 0. So when we graph our line, we're only going to use the part of the graph that uses the x values of 0 all the way towards -infinity. So here's our line. Next, we're going to graph the bottom equation. For the bottom equation, this only uses the x values that are greater than 0. So for our x and y chart, we use the x value of 0 and then anything above 0. So I'm going to use 1. Notice here I chose to use 0 even though it states that x is greater than 0. The 0 that we choose here is going to act as a placeholder. So when we graph this point on our graph, we'll actually use an open circle, meaning that this point is not included as part of our graph. Again, this will act as a placeholder so that we could graph our line. So when we plug in the x value of 0 into the bottom equation for x, we get -0 minus 1, which simplifies to -1. So our f of x value in our chart is -1. For x equaling 1, we plug that into the bottom equation for x. We get -1 minus 1, which is -2. So our f of x value in our table is -2. Now that we have both of our x and y values for our points, we could go ahead and plot them. So we have one point at 0, 1, and remember this one's going to be an open circle. Next, our second point is at 1, -2, and then we could go ahead and draw our line. So this is the final graph of our piecewise function. Moving on to part B, we have the piecewise function f of x equals 5 if x is less than -2, and then f of x is equal to 3 if x is greater than or equal to -2. Again, we're going to use the point plotting method. So for the top equation, we have f of x equals 5 for x values less than -2. So the x values we're going to use on our table will be -2 and anything less than -2. So I'm going to use -3. Remember, at -2, this is not included in our graph, so we're going to graph an open circle at that point. Next, we're going to take x equals -2 and plug it into the top equation. Notice that there's no x variable in the equation. This means that our corresponding y value will always be 5. So the f of x value in our table will be 5, and the same thing for -3, the f of x value will be 5 as well. Now that we have our 2 points, we could go ahead and plot them. So we have our first point at -2, 5, and remember this is going to be an open circle. And then we have our second point at -3, 5. Next, we draw a horizontal line going to the left because this part of the graph only uses the x values less than -2. Next, we're going to graph the bottom equation. So the bottom equation only uses x values that are greater than or equal to -2. So in my x and y table, I'm going to use the x value of -2 and then anything greater than -2. So I'm going to use 0. Next, we take x equals -2, plug it into the bottom equation. However, there's no x variable there, so our y value will always be 3. Same thing for x equals 0. The corresponding y value will be 3. Now that we have our x and y values for our point, we could go ahead and plot them. So our first point is at -2, 3, and then our second point is at 0, 3. Since the bottom equation only uses the x values greater than or equal to -2, we draw our line going to the right of -2. So this is the final graph of our piecewise function. Next, we have another practice problem. Graph the following function. Here we have f of x equals 3x plus 4 if x is less than or equal to 0, and f of x equals -x plus 2 if x is greater than 0. So go ahead and pause the video, try out this problem, and then check back with the video to see how you did. Alright, so let's get started graphing the top equation. For the top equation, we only use x values less than or equal to 0. So on my xy chart, I'm going to use the values of 0 and -1. When we plug in 0 into the top equation, we get the value of 4. So our f of x value is 4. When we plug in x equals -1 into the top equation, we get the f of x value of 1. Now that we have our x and y values for our 2 points, we could go ahead and plot them. So our first point will be at 0, 4, and our second point will be at -1, 1. When we graph our line, we graph it going towards the left of 0 because our line only uses the x values less than or equal to 0. Next, we graph the bottom equation. The bottom equation only uses the x values greater than 0. So in my xy chart, I use the value of 0 and 1. When we take the x value of 0 and plug it into the bottom equation, we get the f of x value of 2. Remember, this point will actually be an open circle. Next, when we take the x value of 1 and plug it into the bottom equation, we get the f of x value of 1. Now we could go ahead and plot our 2 points. So we have an open circle at 0, 2, and then a point at 1, 1. Next, we draw our line going through the 2 points, and our line will go towards the right of 0. So this is the final graph of our piecewise function. Alright, so we reached the end of our video. Thank you for watching. I'm Professor Diwa, and I'll see you in the next one.